A sensor malfunction warning light indicates that one or more of your vehicle's sensors aren't working correctly. These lights serve as your car's way of communicating potential problems that need attention. Modern vehicles from 2022 to 2025 have sophisticated sensor networks. Premium vehicles now contain over 100 sensors, compared to just 30 to 40 sensors in vehicles from the early 2000s. These sensors monitor various aspects of your vehicle's operation, from engine performance to safety systems. The warning lights are part of the vehicle's onboard diagnostic system, known as OBD2. Common types of sensor warning lights include the check engine light, which is often triggered by emissions-related sensor failures. This is the most frequently encountered warning light in modern vehicles. Other important warning lights include the ABS warning light for anti-lock braking system sensors and various safety system indicators that monitor critical vehicle functions. Understanding what these warning lights mean is the first step in addressing potential issues. Each light corresponds to specific sensors and systems in your vehicle, helping you identify what needs attention. Sensor malfunctions in vehicles stem from several key factors. Understanding these causes and knowing how to address them is essential for maintaining vehicle reliability and safety. Environmental factors are the leading cause of sensor failures, accounting for 40% of all malfunctions. These include moisture infiltration, temperature extremes, and corrosion from road salt. Electrical issues contribute to 30% of sensor failures. Wiring harness damage and connector corrosion are the most common electrical problems that affect sensor performance. Physical damage accounts for 20% of failures, including impact damage from road debris and general wear and tear from vehicle operation. Age-related degradation represents 10% of sensor failures, as components naturally degrade over time and lose calibration accuracy. When a sensor malfunction warning light appears, a systematic diagnostic approach is essential to identify and resolve the issue effectively. The first step is performing an OBD2 scan to retrieve diagnostic trouble codes. These codes provide specific information about which sensor or system is malfunctioning. Next, perform a visual inspection of the sensor, wiring harness, and connectors. Look for obvious damage, corrosion, or loose connections that could cause the malfunction. If visual inspection doesn't reveal the problem, electrical testing is the next step to verify proper sensor operation. Electrical testing using a multimeter verifies that the sensor receives proper power and ground connections and that signal integrity is maintained throughout the circuit. Modern automotive technology is moving toward predictive maintenance systems that can identify sensor issues before they cause failures. Artificial intelligence and machine learning are revolutionizing sensor diagnostics. These systems analyze sensor performance patterns to predict failures before they occur, reducing unexpected breakdowns by up to 35%. Predictive maintenance systems identify potential issues early, reduce repair costs, improve overall vehicle reliability, and enable proactive maintenance scheduling rather than reactive repairs.